project.
Well, thank you for the invitation. It's a pleasure to be here. Before I start, somebody from security came over to ask me to relay the message that if you're leaving the room, you should take your stuff with you. So, message relayed. So this field campaign, Bbop, was done in 2013. We had a total of about 35 research flights. One of the unique things was that it was an extended deployment covering several months, which is unusual for aircraft study, and that was made possible by doing the Wildland fires out of Pasco, Washington, where the aircraft is based. Now, I'm not going to try to just give you an overview of Bbop other than to say that we were most interested in the near-field evolution of aerosol properties. So aerosol and trace gas emissions, growth of aerosol mass, and downward evolution of these quantities. And I'm going to touch on the growth of aerosol mass, size distribution, and chemical composition. So the experiment was split into two parts, and this is really, the diagram refers to the first part. Several months in the northwestern United States, and then we moved to Memphis, where we were there almost a month looking at prescribed agricultural burns. And along the way, we had 7 flights looking at urban areas for contrast, overflights of Mount Bachelor Observatory, one collaborative flight. I hope I get through it all, concentrate on 3 fires, mile marker 28, 7/26, July 26, Colockum Tarp, and government flats. And you'll see here the number of acres that are burned, 26,000, 80,000, 12,000. So these are pretty big fires going on for several days. But the really big one was the rim fire, which was 250,000 acres. But unfortunately, a little too far for us to get to. So the question that we first posed is SOA formed in wildland fire plumes? And to address that, we need fires to sample, a measure of SOA or some surrogate for SOA, a conservative tracer to account for dilution, and some time markers to get a rate of change. Now, I've listed here different elements, SOA or surrogate. These are measurements that were made aboard the G1 aircraft. So we have direct measurements of organic aerosol from an AMS, 2 particle sizes, and scattering as a surrogate. Conservative traces, we have a pick of several. CO, 2 ways of measuring BC, and a few non-reactive species that were measured with the PTRMS. Age, we have WINS, NOx over NOI, and toluene over benzene. If you do the multiplication, using just the ones I listed here, 4 SOAs times 5 traces times 3 ages, 60 different answers that we can get for this problem. And let's then multiply that by the number of ways of subtracting background. Although I won't be putting deltas in front of every variable, these are all quantities in which backgrounds are subtracted. So one can imagine that you could get a fairly wide range of answers to the question of how much and how fast is SOA formed in a wildland plume. The first fire was the mile marker 28. it shows a flight pattern color-coded by a scattering. You see these are quite high values, this is megameter, inverse megameters. And that fire actually was not far from where the aircraft was based, and you can actually smell the smoke at the airport. So we have really two sets of transects, and these almost constitute a true Lagrangian experiment, where what we measured on the first transect we measure an hour later on the second transect, although it's not analyzed here in that fashion. In most cases I was negligent or didn't get to it, putting an hour age on the x-axis, so you'll see transects number rather than an absolute age. Scattering over CO, you could see a nice increase. This turns out to be one of the more reproducible and I think robust indicators of the formation of mass downwind, and as the aerosol is 90% or so organic, measuring mass or volume is essentially the same as measuring organics. And here's a more direct measurement, organic over CO, and if you look very carefully you'll see, well, maybe not so carefully, you'll see that there are differences in the magnitudes. Second fire, Colockum Tarps. Again, the same idea. We have multiple transects across the fire, repeating the sampling pattern twice, looking at a few different quantity here, NOx over NOY, and there's amazing reproducibility between the first and second set of transects, color-coded black and blue here, and there's quite a drop-off from a ratio of 0.6 to 0.1 in this time period, which corresponds to about 3 hours. Looking at let's see, organic over CO, it's showing about a 25% increase in SOA over this time period, and in contrast to this behavior where the two traces lie on top of each other, we do see differences between the two sets of transects. Okay, I'll spend most of my time on the government flats fire. This is a pretty complicated diagram to follow your way around, but what we did was start near the source, work our way backwards out to a position that's a little less than 2 hours away from the center of the fire, and then go along the plume. So what will be shown are data that come from the plume transects. These are color-coded boxes. I don't know if you can make them out. And that is in black, and then the observations that are made going along the plume are in blue. And there are these two unconnected points, because after we did the along plume observations, we went back and went across the plume twice. So that's this. So I think this shows a real change in the plume in the time that it took us to go first outwards, making transects, then back along the plume, and coming back and doing really the same transect. So these points here should fit on this curve but it appears that there's a change over the course of a couple of hours in the behavior of the plume. So this is an example of an extensive variable CO concentration. Although not indicated, background has been subtracted. So you could see the variability, and concentration is quite high, going up to 8 parts per million. The other panel is of an intensive variable, the modified combustion efficiency, and it shows some of the same looking features, but all in all, this range is actually quite narrow. So there are a lot of things that depend on MCE and are kind of sensitive to it in this range, but maybe it's a small enough range that we don't have to worry about it that much. Looking at size distributions, this, we have measurements from the FIMS, which is collecting size spectra at a rate of 1 second over size range 25 to 250, 300 nanometers. Near the fire, we have Aiken mode, and you could see an accumulation mode growing in as you go downwind, and the Aiken mode disappearing. This first thought was that this is an ideal case to look at coagulation. You have kind of high concentrations of small particles over some size range. The calculation has not been done, but looking at the total number from the FIMS, dividing by CO to normalize it, the average value over these 5 transects is this number, and you see the standard deviation is really not very large. So we don't see any evidence of particles disappearing. If we look at the FIMS volume divided by CO, we do see that the particles are getting larger, and here's where the volume is. So this is consistent with more aerosol being formed. This is a long plume. We're going toward the fire. One thing I want to draw your attention to is the nitrate and the ammonia and the sulfate. We do have sulfate here, and the nitrate, the ammonia has been scaled to the nitrate by multiplying by a ratio of molecular weights. And I had to put symbols on one of these on the nitrate so that you could see the difference here. So there is enough ammonia to neutralize nitrate, no more, no less. This is very odd, as sulfate should really be grabbing the ammonia, and if there's any excess nitrate, it should be evaporating. One of the things that we don't have an explanation, but one possible explanation is that the sulfate is in the form of sodium sulfate or potassium sulfate. In the interest of time, maybe I'll skip over these, showing more time evolution, nephelometer versus CO, AMS versus CO, somewhat different results. And finally, thank you for your attention, and if the moderator allows me, I will answer questions. Thank you.